Welcome dear students. Today we are back with a good problem on Newton's laws of motion. So if you attempt it, then definitely you will get a great clarity in terms of Newton's laws of motion. So here you see it is an assembly in which three identical cylinders are kept on a horizontal surface. All the surfaces are perfectly smooth. There is no friction anywhere. So this assembly, this cylinder is being pushed by a force F, and the question is what should be the range of this force so that all the cylinders remain in contact with each other. So essentially they mean to say that these cylinders should always be intact and they must not separate. So you need to just see why they will be separating, if at all. Let us start the question. Let us say the situation is like this, and if the force is very low, I mean the volume of the force is very less, I mean let us say this is the force which is acting on this, and if it is very low, then what will be the situation? As an extreme case of very low, let us take f equal to 0. Definitely we can take, because low means we can take any lowest value of f. So I am taking f equal to 0 just to make you visualize the situation. If f is equal to 0, what will happen? Simply this ball will be feeling a weight force mg. Because of this weight force, this surface, this will be feeling some normal reaction. Let us say n, this ball will be feeling some normal reaction. Similarly, this ball will be feeling some normal reaction, and these normal reactions will have some horizontal components. Because of these horizontal components of forces, these two balls will separate. This one will move this side, this one will move this side, and this block will come down in the space between them. Situation will be something like this. Here you see this ball will be moving this side, this ball moving will be this side, and this will be entering in between them. This is the situation when f is very low. In fact, 0 I have taken. Now, what is the situation when f is very high? F is very high. F is very high. So, now you see what is happening. Initially, this is the situation. What will happen when the force acting on this ball is having a very high value? Can you think of it? If you cannot think, just imagine yourself sitting in a car which is accelerating very fast, in this direction. What will happen to this ball? In the frame of this ball, this will be experiencing a pseudo force in backward direction, and because of this pseudo force, this ball will try to jump over. Jump over means it will try to separate from this ball. So situation will be something like this. If force is very high, then these balls will tend to separate, because this ball will be trying to go back with respect to this ball. Very similar to the car example I gave. In the moving car, things tend to go back. Similarly, this cylinder will tend to go back. So if force is very low, these two cylinders will separate. If force is very high, these two cylinders will separate. So our aim is that none of them should separate. Neither this one should separate, nor this one should separate. So what should we do? We should find the range of a force which keeps them intact. So let us see how to approach it. This is the situation, and this is the force on it. Assuming that they are all intact, so we can assume this to be a rigid body, isn't it? It will be a rigid body having mass 3m. So let us say if it is moving with acceleration a, we can clearly write f equal to 3ma. Remember this equation, it will be used in a later stage. Okay. Now, in this assembly, all the bodies are moving, but you want to get rid of, and you want to analyze this problem from the frame of reference of this ball. Okay, let us call this ball A. We want to analyze the situation from this ball, but this ball is already an accelerated frame of reference. So what we are supposed to do, we are simply supposed to apply a backward pseudo force ma on this ball, similarly ma on this ball. If you apply these pseudo forces, then the problem becomes very easy, because now we can assume this ball to be at rest. This ball will be rest, and simply two forces will be applying. So situation is something like this. Now this ball is at rest, I mean it is intact with the ground, and these two balls are having extra forces, pseudo forces ma and ma, apart from all the other forces like gravity, the normal reaction. So these two extra forces we added, and we make this ball at rest. So this is the beauty of changing the frame of reference. You can get rid of the motion and you can easily analyze it. So now with these pseudo forces, let us see how the problem becomes easy. This is the situation, and you see what are the forces. Let us draw the forces which are acting over here. So if we take this ball, so first force is mg downward. Other one was, we already told, ma, which is pseudo force, ma in this direction. And similarly, let us say the normal reaction at this point is n1. I mean this ball is feeling normal reaction n1. Since the system is at rest, this ball is at rest, and all the balls are in fact at rest. So the normal reaction appearing on this ball, this will also be n1. Okay, and on this surface, let us assume the normal reaction is something n2. That means on this ball also it will be n2, Newton's third law. Okay, let the normal reaction along this surface be n. That means this surface will be feeling normal reaction n, and this ball, this surface will be feeling normal reaction n. Now since all the balls are symmetrical, this triangle which is shown in the dash line, this is 60 degree. I mean all these angles are 60 degree. Now what do you think our strategy should be? If the ball should not leave the contact here, ball must not leave the contact here, that means our n should never be less than 0. N should be greater than 0 always, in order to ensure that these two balls remain in contact, because if n becomes 0, that means they lost the contact, which we don't want. So n should be greater than 0. This is our first condition. Second condition, what we can say, you see along this surface, we have already seen that if force is very high, then the contact was breaking along this surface. So here also we want n2 should never be 0. n2 should always be greater than 0. So what we can write? We can write n2 should be greater than 0. These two conditions we need to always fulfill. Okay. So now let us just write the simple equations of, simple Newton's law equations. So if you see the free body of this ball, okay, what are the vertical forces? One because of this n1 component, other here. This angle 30 degree. So we can clearly say n1 plus m2, n1 plus n2 times n1 plus n2 cos 30 degree means root 3 by 2. Root 3 by 2 should be what? Vertical. Vertical force is what? mg. Should be mg. This is the first equation. Okay. Second, we need to balance the horizontal forces in this direction. So horizontally, you can easily say this component of N1 horizontal and this component of N2, they must balance the MA. So what we can say, N1, you can see, using the directions, you can easily say N1 minus N2 cos 60 degree. The angle is now 60 degree. Cos 60 degree means 1 upon 2. This should be equal to what? It should be M times A. These two equations. So we got horizontal equilibrium and vertical equilibrium for this ball. Now let us come to this ball. We don't need the vertical equilibrium condition because already if any time it is moving in horizontal. So we will consider only the horizontal motion. So horizontal motion, what we can say here, I forgot to mention one pseudo force is also acting here, which is MA. As the pseudo force was acting here, so the pseudo force was acting here. Now you apply N, N2 and MA. Apply horizontal equilibrium. N2 horizontal component is this, N1 this. So easily we can say N plus N2 cos 60 degree, that means N2 by 2. N2 by 2. This is what? This is again M times A. So we got three equations, and now the condition has become very easy, and you can easily, if you do 1 minus 2, what we get? Because see, our aim is what? Our aim is we need to get N and we need to get N2 in terms of acceleration, because acceleration is in terms of force. So using N and N2 condition, we can easily get the limits on force. So 1 minus 2 gives what? 1 minus 2. Clearly you say it gives you N2 is equal to, if you do and solve, you get N2 is equal to M times G by root 3 minus A. G by root 3 minus A. Okay. Now if you put this value of N2 in third, you get N is equal to, M by 2 3A minus G by root 3. This is simple mathematics, you can easily do. Okay. So you see these two equations are giving you, let this call equation 4 and this equation 5. These equations are easily giving you the condition. Now you see N equal to 0 gives you what? N greater than 0. As we have already decided that N should be greater than 0, it gives you A is greater than 3A should be greater than J by 3 J upon under root 3. So A should be greater than G upon 3 root 3. This gives you what? 3MA should be greater than what? Mg by root 3. Mg by root 3. But you remember what was our 3MA? If you don't remember, let me show you what is 3MA. 3MA is nothing but our force. So here you see 3MA is nothing but force. So this gives you condition F should be greater than Mg upon root 3. Greater than or equal to Mg. Okay. So you got the minima of F. Now for maxima, what you get? N2 should be greater than 0. You can see here N2 should be greater than 0. N2 should be greater than 0 gives you what? You have already got N2 from this equation. So here you get G by root 3 should be greater than A. That means from here you get A should be less than G by root 3. That means 3MA, if you put 3MA should be less than what? 3 MA should be less than mg root 3. But we already know what is 3 MA, it is F. So F is less than root 3 m times g. So this is what we get the maxima of F. So you got this range. You can easily say here that this minimum F should be this one and maximum F should be this one. So initially the final answer is mg upon root 3 is the lowest range and F, the applied force, is under this value. So within this range, if your force lies, then all three cylinders will remain in contact. So this is the approach by which you can attempt such questions. So if you have any doubts, any queries, any questions, please do ask in the comments. I will be happy to reply it. Thank you very much.